All right, folks, we are on the last section of the first half of chapter 7, which is going to be over dividing polynomials. Okay, with two learning, or really one learning target that we're going to focus on today, which is that you're going to be able to have the ability to divide polynomials. And this is how we're going to grade it. Okay, these first 2 pages are just kind of over the tile activity that you should have done in class already. So we're going to skip all the way to 7-4, page 3. Okay, what we're going to do first is we're going to work on some just basic division of polynomials, and specifically a binomial divided by a monomial, binomial 2-term, monomial 1-term. Okay, so here's the first thing that we're going to do. 6x squared plus 12x all divided by 3x. So what we can do is, since we have these parentheses, this whole thing is being divided by 3x. So what we're going to do is divide both parts. 6x squared will be divided by 3x. And then 12x will also be divided by 3x. Okay, so we're going to divide both parts by 3x. And then we just have to do a little bit of division. So 6 divided by 3 is 2. X squared divided by x. So I have 2 x's, x squared, x times x. And I'm dividing 1x away. So what's left over is just x, or x to the first. Okay. Kind of visualize that. You might want to think about x squared being x times x. And I'm dividing it by x. One of those x's is going to cancel out. And I'm left with just an x to the first. Here, 12 divided by 3 is 4. X divided by x, all the x's are divided away, and it's just 1. So 4 times 1 is 4. Okay, 1b. So here I have 14x cubed, and I'm going to divide it by 7x squared. Then I'm going to minus 7x squared divided by 7x squared. Okay, kind of same thing, just multiply or divide the parts that are there. So 14 divided by 7 is 2. Okay, x cubed divided by x squared. So here's x cubed, and I'm dividing it by x squared. Okay, and so then what we're going to do is we're going to divide each of these parts here, and I am canceling each of them out, and all that's left here is an x squared. Or not an x squared, but rather just 1x. So that these are all x to the first power. So all that's left is an x. Okay, here we're going to do the same thing. Okay, and 7 divided by 7 is 1. And you can kind of think about on the right side, x squared is x times x. And I'm dividing it by x squared, which is x times x. Okay, these each cancel each other out. So there's no x's left. And so we're just left with whatever this division is, which is 1. Okay, same process as always. Go ahead and take a moment to try monitoring progress 1 and 2 and check it with me when you're done. Okay, so first things first is we're going to try to establish what this is going to be. So each of these is being divided by 4. So we're going to divide each of them by 4. Okay, this one's a little bit easier because there's no variables that need to be divided. So I have 8x and I'm dividing it by 4. That's going to be 2x. And then I'm going to take 24 and I'm going to divide it by 4 and get 6. Okay, 12, same thing. I have 20x squared and I'm dividing it by negative 5x. And then I have 5x and I'm dividing it by negative 5x. Just do it in the parts. 20 divided by negative 5 is negative 4. X squared divided by x is x. 5 divided by negative 5 is negative 1. X divided by x cancels out. So just negative 1 times 1 is 1. Okay, so that is just kind of like real basic division. What we're going to work on now is some polynomial division. Okay, when you divide a polynomial, f of x, by a non-zero polynomial divisor, d of x, you're going to get a quotient polynomial, q of x, and a remainder polynomial, r of x. So that sounds really, really kind of complicated. Really what it is you're going to take one polynomial and divide it by another. And you're going to get some answer, but you may get a remainder, okay? And we're going to see what that looks like in a little bit more straightforward example here. Okay, the degree of the remainder must be less than the degree of the divisor. Okay, when the remainder is 0, that means the divisor divides evenly into the dividend. Also, the degree of the divisor is less than or equal to the degree of the dividend f of x. Okay, one way to divide polynomials is polynomial long division. And so that's what we're going to work on first. Okay, so here the first part is going to be the dividend. And the second polynomial is going to be the divisor. Okay, the thing that's very nice is that if I want to take 7 divided by 3, the process is actually the same as what you're going to do with polynomial division. You can take a 3 here, divided by 7. Okay, and you're going to ask yourself, how many times does 3 go into 7? And we know it goes in there twice. And when 3 goes into 7 twice, I get a 6. And so what's left over is 1. 3 does not go into 1, so that means 1 is the remainder. So that means my answer here is 2, remainder 1, which is, in this situation, 2 remainder 1, in this situation would be 2 in 1/3, right? Because 1 left over out of 3 is 1/3, okay? But it does fit in there 2 whole times. And that's essentially what we're going to be doing today. So what we're going to do is start with the dividend and the divisor. Okay, so really all you want to do is get the first terms to match up. You're going to ask yourself, what do you have to multiply x by to become 4x? And you have to multiply x by 4 to become 4x. Okay, so because x times 4 is 4x, we want these to match up perfectly. And so here, then you have to go back and multiply this whole thing by 4. 4 times x is 4x. 4 times 1 is 4. And just like what we have here is once I do that multiplication, 3 times 2 is 6. Then I subtract, you're going to do the exact same thing here. And I have something popping up on my screen. One moment. Okay, so again, just like I go 3 times 2 is 6, and then I subtract, I'm going to go 4 times x plus 1 here, and then I'm going to subtract. Here, the 4 x's would cancel out, and then I'm left with 5 minus 4, which is 1. Okay, so then now I have this number 1, and I want my x to become a 1. Well, the degree of 1 is less than the degree of x plus 1, so that means this is going to be my remainder. So my answer here is 4 remainder 1. Okay, so 4 remainder 1, which is going to be 4 plus 1 divided by x plus 1. Okay, same thing here. My remainder was 1 because the 3 doesn't fit into 1. So what's my last part left over? It's 1 over 3. And here it's the same thing. Here's my remainder 1. So it's going to be 1 over x plus 1. And this is my answer. So that's exactly what this part at the top was showing you, is that here's your quotient. My quotient's 4. I have a remainder of 1. And then D in this situation is the divisor, which is this outside part. Okay, let's go ahead. Let's go to the next one. Monitoring progress 3 is here, so don't forget about that one, but we are going to go to the previous page, or the next page, rather, and just continue to do the exact same thing, just a little bit more complicated problems. Okay, so I'm going to take 3x plus 4, and I'm going to divide it by 6x squared plus 17x plus 20. And I want to do the same thing. I want to make 3x into 6x squared. I want to get them to match up perfectly. So because I want to do that, I got to ask myself 3 times what number is 6? Well, 3 times 2 is 6. And then I want x to become x squared. So what do I have to multiply x by to become x squared? And it's x. Okay, so once I figure out what that quotient is, then I have to go 2x times 3x, just 6x squared. And then I have to go 2x times 4, which is 8x. And then I have to subtract. Okay, 6x squared minus 6x squared cancels. 7x minus 8x is 9x. And then this 20 doesn't do anything. It's going to drop down. Okay, the degrees here are the same, x to the first, x to the first. So that means I can do this exact same thing. Again, you have to go until this degree is less than this degree. Okay, so now what we're going to say is, what do I multiply 3x by to become 9x? So we're going to multiply by 3. 3 times 3x is 9x. And then I multiply this 3 by everything here, and we'll write it here. 3 times 3x is 9x, as we wanted. 3 times 4 is 12. Okay, once you get that answer, again, you're going to subtract. And then you go 9x minus 9x is 0, so it cancels out. And I have 20 minus 12, which is 8. Okay, so then now what I want to do is, again, I want to try to get these to match up, but I have an issue because the degree of 8 is 0, and the degree of 3x plus 4 is 1. This degree is higher than this degree. Therefore, this is my remainder. So my answer is 2x plus 3, remainder 8. So 2x plus 3, remainder 8 is going to be 2x plus 3 plus 8 divided by 3x plus 4. And this is my answer right here. Okay, last one to C of the long division. Long division is a lot harder than synthetic division. Okay, the first thing that I want to do is I want these in standard form to the best of my ability. And if I'm skipping a term, you want to include that term as part of the work. So here, for example, I have 3x squared, then x to the first, then no x at all. I want to have that to be true for all of these. So here, instead of 1 plus x squared, I'm going to rewrite this as x squared. And then I'm missing that regular x to the first power term. So I'm going to include a 0x plus 1 because I am missing that term completely. So I'm just going to rewrite it as x squared plus 0x plus 1. Okay, and then what you're going to do is the same thing that we did before. We're going to have x squared plus 0x plus 1, and we're going to divide it by 3x squared plus 2x plus 15. Okay, you're going to try to get these to match. What do you multiply x squared by to become 3x squared? You're going to multiply it by 3. 3 times x squared is 3x squared. 3 times 0 is 0x. And 3 times 1 is 3. Once you get that quotient part down and you multiply, you can go ahead and subtract. Okay, and these cancel. 2x minus 0x is 2x. 15 minus 3 is 12. Then you want to try to get those parts to match up again, but like we've seen before, the degree here is higher than the degree here. So what does that mean? That means this is your remainder. So now I have 3 remainder 2x plus 12. So my answer is 3 remainder 2x plus 12, which is 3 plus 2x plus 12 divided by x squared plus 1. And we have that 0x there here also, just so you can see that it's just kind of a nice placeholder to make sure that we're keeping track of the work and making sure I'm adding or subtracting the like terms together rather than splitting those all up. Okay, so what I would do now is, if I were you, I'd pause the video and take a moment to try monitoring progress 3, 4, and 5, and check it with me when you are done with those problems. Okay, as usual, I'm under the assumption that you've already done that and you're just looking to see how you check your work. Okay, so this one here, I'm going to go x plus 3. And then divide it into 5x plus 4. I'm going to try to get these to match, x and 5x. So what do I have to multiply x by to become 5x? It's 5. So then I'm left with 5x plus 15. And then once I have those, I subtract. Now you got to be careful, because I imagine a lot of people will want to put 11 here because -4 and 15 is 11. But remember, we're subtracting. Negative 4 minus 15 is negative 19. The degree of x plus 3 is larger than the degree of negative 19. Therefore, this is your remainder. And my answer is going to be 5 plus negative 19 over x plus 3. All right, let's go to the next page. Back to 4. Okay, same process on repeat. Okay, we're going to take x minus 2 here, and we're going to divide it into 7x squared plus 4x plus 11. Always try to get the first terms to match up. So you want to say, what do I multiply x by to become 7x? Well, what do you multiply 1 by to become 7? It's 7. And what do you multiply x by to become x squared? Well, the answer to that is x. Okay, so then you're going to take this 7x and you're going to multiply by x minus 2. 7x times x is 7x squared. And 7 times negative 2 is negative 14x. Once you have those, you're going to subtract. 7x squared minus 7x squared cancels. Okay, also have to be careful here. 4x minus negative 14x. Minus a negative is addition. So 4x minus negative 14x is 18x. And then I'm going to drop this 11 down. Then what I'm going to do is I'm going to continue to multiply. I want to ask myself x times 18, or not x times 18. What do I multiply x by to become 18x? Well, they already have the x variable with the same degree, so I just have to multiply x by 18 to go ahead and make that happen. So 18 times x is 18x. 18 times negative 2 is going to be negative 36. And I subtract. Again, here I'm minusing a negative, so you need to be careful. 11 minus negative 36, check it in your calculator if you have to, but 11 minus negative 36 is the same as 11 plus 36, which is going to be 47. The degree of x minus 2 is larger than the degree of 47, so this is my remainder. So my answer is going to be 7x plus 18 plus my remainder 47 divided by my divisor x minus 2. Okay, last of the long division examples before we start synthetic division, and that's going to be number 5. Okay, same thing. The only difference here is I want to write this with the x term represented. So instead of x squared plus 5, I'm going to write x squared plus 0x plus 5. And then I'm going to include that into my work here. So I'm going to have x squared plus 0x plus 5. And I'm going to divide that into negative 6x squared plus 2x plus 18. Okay, first things first, I want to understand, what do I multiply x squared by to become negative 6x squared? I need to multiply it by negative 6. Negative 6 times x squared is negative 6x squared. Negative 6 times 0x is 0x. Negative 6 times 5 is negative 30. Once I have that all multiplied through, again, you are going to subtract. Negative 6x squared minus negative 6x squared is 0. 2x squared minus 0x squared is 2x squared. 18 minus negative 30, 18 plus 30 is the same thing, so that's 48. I know that this is the remainder because the degree of this term is larger than the degree of this. Therefore, my answer is just going to be negative 6 plus 2x plus 48 divided by x squared plus 5. And that's long division. Okay, so last thing that we need to try to tackle today is synthetic division. So there is a shortcut of dividing polynomials of the form x minus k. Okay, so where k can be positive or negative. So really, your synthetic division really is only going to work when it's a a linear expression, meaning it's going to be in the form like x plus some number or x minus some number. Okay, and this shortcut is called synthetic division, and the method is going to be shown below. Okay, the first thing that you're going to want to do is you're going to set up a little upside down division bar. And quite honestly, synthetic division, in my experience, is a lot easier than long division. But again, it only works. So if I have an x squared, not going to work. But if I have a linear expression, just x plus a number or x minus a number, it will work. Okay, the first thing you're going to do is you're going to place these values in here. Okay, inside your division bar in order of standard form. So 3, -10, and 20. Okay, the next thing is you're going to put that k value out here, but you have to be careful because it looks like to most people k is -1 or -2 here, but in reality it's actually +2 because it's x minus that value. So generally speaking, it's just going to be the opposite of what it appears to be. So it appears to be -2, so I'm going to put a +2 out here. And then you're going to follow this procedure on repeat until you just can't do it anymore. Ready? The first thing you're going to do is you're going to drop the 3 down. And then you need to figure out what this number is. To find out what this number is, you're going to take 2 times 3, which is +6. Since it's +6, I'm just going to put a +6 there. And the reason why I'm putting the +6 there is because then it tells you what math operation to use. -10 plus 6 is -4. Then what I'm going to do is I'm going to figure out what this number is here. And to figure out what this number is here, I'm going to go 2 times -4, which is -8. And then once I write it with the sign, it tells you what math operation to use. 20 minus 8 is 12. Now, it may not seem like it, but I actually kind of have my answer, which is convenient because this farthest right number will always be my constant. Okay, my remainder. My next number will always be my constant value. So that's a value without a variable. The next one to the left will be my x to the first power. If I had another one to the left of that, it would be x to the second power. And if I had another one to the left of that, that'd be x to the third power, and x to the fourth, and fifth, and sixth, etc. It could go on forever. So in this situation, what's my answer? My answer is 3x minus 4 with a remainder of 12. Which means my answer is 3x minus 4 plus 12 divided by what I'm dividing by, x minus 2. So this is my answer here. Okay, 3b is essentially the exact same thing. The only difference is that I have more than 3 terms, which is fine. You can just continuously tack on terms if you wanted to do this over and over. My first number would be 1. My second one would be -12. My third one would be 45. And my last one would be -70. The number that goes out here, again, got to be careful. I think most people would think it's -7, but it's actually going to be +7. Okay, and then you just do the same process. You're going to drop the first number down to get a 1. And then to find this number, I'm going to go 7 times 1, which is +7. -12 plus 7, -12 plus 7 is going to be -5. And then to find this number, I'm going to go 7 times -5. 7 times -5 is -35. 45 minus 35 is 10. 7 times 10 is +70. -70 plus 70 is 0. This is going to be my remainder. This is my constant. This is my x to the first power. And this is my x to the second power. So my final answer is just going to be x squared minus 5x plus 10. Okay. One thing that I would like to talk about is this here. When the remainder is 0, like we talked about at the beginning, when you divide one number by another and the remainder is 0, that means it divides evenly into it. Imagine me taking 6 and dividing it by 3. I get 2 with no remainder. That means 3 divides evenly into 6. So when my remainder is 0 here, that means x minus 7 divides into x cubed minus 12x squared plus 45x minus 70 evenly. So that will be a pretty important concept when you do some algebra 2 work. Okay. Pause the video, take a moment to try the monitoring progress problems on the next page, and then check it off with me when you're done. Okay, so I'm assuming that you've taken the time to try those problems. Let's go ahead and work through them now. Okay, I got to set the problem up first. I'm going to have a positive 3 on the outside of my synthetic division bar because it's the opposite of whatever this appears to be. The coefficients here are 2, 1, and 3. So that's what's going to go on the inside. I'm going to drop the 2 down, make it a 2 here. And I'm going to find this number by going 3 times 2, which is 6. And then it's a positive 6. So I'm going to add 1 plus 6 is 7. Then I'm going to find this number. 3 times 7 is 21. And then this number here is 3 plus 21, which is 24. This is my remainder. This is my constant, and this is my x. So I'm going to get 2x plus 7 plus my remainder divided by my divisor. Okay, number 7, again, we set up the bar. I'll have a negative 4 out here, and then negative 1, 5, and then negative 2. I'm going to drop my negative 1 down and go negative 4 times negative 1 is positive 4. I'm having something pop up on my screen again. 5 plus 4 is 9. Negative 4 times 9 is negative 36. Negative 2 plus negative 36, or negative 2 minus 36 is negative 38. This is my remainder. This is my constant, and this is my x. So my final answer is going to be negative x plus 9 plus negative 38 divided by x plus 4. And I'm done. Okay, so what we're going to have now is just a little bit of work time for your practice problems. Here is what you need to do. Okay, you're going to work on number 21 through 28. Pick any 2 you'd like. And then you can work on also 29 through 36. And you can also pick any 2 you'd like.